Welcome, everyone, to the next iteration of the Kaggle Generative AI Intensive course. We're really excited to have over 250,000 developers dialed in today to learn all about the Gemini APIs, AI Studio, Vertex AI, and all of the wonderful AI features that Google Cloud has been putting out over the last several months. But before we begin, I really want to welcome onto the stage someone very special, our chief scientist at Google, who wanted to be here today to give you a short message. So with that, let's welcome Jeff Dean.
Hi, everyone. Jeff Dean here. I'm super excited you've all decided to join the Kaggle GenAI intensive course. We ran this course last year and we had about 150,000 developers sign up. We're running it this year. It looks like we'll have more than 200,000, which is pretty amazing. And really, we're excited to see what people do with these generative models. There's so many possibilities in terms of creating, useful things that help people get things done, things that entertain people, things that help people, take information and transform it into different kinds of modalities. And the capabilities of these models are increasing quickly. So that means that the building blocks that we all have as developers are growing in, sophistication, and that enable us to do more and more interesting things. So we're really, really excited about what you all are going to do, what you're all going to learn to do. And that's why we're running this course. And we're looking forward to answering questions and giving you, guidance about how to use these tools and seeing how you all use them. Super exciting. Thank you.
Excellent. And thank you so much, Jeff Dean. I think that we all have, we've all used many of the products that Jeff has built from the ground up. And so it's wonderful to have him here today to tell us a little bit about what he's excited to see for our students to create. So taking a look back at the slides, just as a general reminder, this 5-day intensive course is hosted by Kaggle. It includes everything from daily assignments to Discord discussion threads, live stream, and Ask Me Anything session, which you're dialed into right now. And as a reminder, this 5-day generative AI intensive course incorporates foundational models, embeddings and vector databases, agents, domain-specific models. And today we are going to be exploring the wonderful world of foundational models and prompt engineering. Just as a reminder, you should have been listening to our summary podcast episode, which was created by Notebook LM. We'll get to hear more from the Notebook LM team later this week. You should have taken a look at some of the white papers that we have around this first day's content. And then also, importantly, the Kaggle Code Lab, which Anant will be walking through towards the end of today. But before we go into this, I want to have a huge shout out to our generative AI course moderators. This is the team that's been tirelessly answering all of the questions that y'all have been asking on Discord. They've been helping spot questions that could be useful in the Q&A session. So thank you so much. Virtual round of applause to everybody who's been making this course happen. If you see them digitally or in person, say thank you. And with that, let's head into our Q&A. So today, I am honored beyond belief to welcome Logan Kilpatrick, Warren Barkley, Kieran Mellon, Arena Ziegler, and Matt Veloso to the stage. They are our expert hosts for day one, all about prompt engineering and foundational models. And with that, I'm going to go ahead and get into our first question. So first question is for Logan and for Matt. And taking a look at it now, tell us a little bit about AI Studio. What capabilities does it unlock for developers, and how does it bridge the gap between Google DeepMind's latest research and all of our great Google Cloud tools?
Want to go first, Logan?
Yeah, sure. I'm happy to, Paige. This is a ton of fun to tell folks about AI Studio and everything that we're doing. The sort of high level mental model of this is AI Studio is intended to be the fast path to access the latest Gemini models, the latest generative AI models coming out of Google and specifically coming out of DeepMind. So if you're a developer and you want to see what's possible with the Gemini models, and Paige, I know you and I do this all the time. You have some idea of what you want to build with AI. AI Studio is a great place to just show up, test, can the model actually do this thing? Does it have this capability baked in? And then with a single click, you can go and grab a bunch of code and actually start building that idea in Python or JavaScript or whatever your language of choice is. You can also get an API key and start building with the API really quickly. So really sort of the path to accelerate idea to actually building something with Gemini.
Absolutely. And I know that just recently we've been focused on unifying the SDKs such that, when you hit that Get Code button, it's a really seamless path to get from AI Studio code to code that works with Vertex AI. So it's been really, really cool to see. Matt, is there anything you want to add?
No, that's what we're going to say. People often ask us why we have two different products, Vertex and AI Studio, and Warren's going to talk about Vertex soon. But we want to have both a unified developer experience, like you all say, like you shouldn't have to choose one or the other before you start coding. Like you can just, pick an SDK and just work with it. But there is value in having two different products for two different types of use cases. AI Studio is very, very simple. It's not an MLOps platform. It doesn't have a model garden with many models, right? It's just Google's models. It's the simplest sort of getting started experience, where Vertex is an enterprise product and it has a bunch of capabilities that AI Studio does not have. So there is value in having these two different things, as long as we have a unified developer experience, so you don't have to write your code twice, and we're doing that.
Excellent. And people can try it out today at ai.dev, I believe, which is the coolest URL that I have seen in recent months. So very, very excited. Thank you for the great answer. Second question for Kieran. How has prompt engineering evolved since the early days of large language models? So as an example, PaLM 2, GPT-3, and the like. How do you think it will evolve over time, especially given the rise in popularity for multimodal models? And you've been doing this for quite some time, I believe.
So this is a fascinating question. I think it's fascinating to look back at the evolution, not just of prompt engineering, but of language models themselves. So if you look at how language models began, they weren't specifically designed to do the tasks that we're using them for now. They were designed as probabilistic models that are able to predict the next token or word in a sentence. And in the early days, we got these models as tools, and really there was a lot of trial and error to find techniques that worked well with them and enabled them to do useful things. So this led to things like chain of thought and few-shot prompting, adding personas, things like that. They were just techniques that were essentially discovered rather than designed. But in parallel, we put a huge amount of work and effort into instruction tuning the models. So this is really us teaching the models how to behave in certain scenarios. This has progressed really rapidly. And it's moving to a future where all the techniques are really designed techniques rather, and they're intentional. So as a team within Google, it's our job to make LLMs as intuitive and easy to use as possible. And when I think about sort of prompt engineering, I think of two sort of sets of personas of user bases. You can think of end users. So those are folks maybe using the Gemini app, trying to use Gemini to answer questions on a daily basis. They may not be experts in prompting. And really what we're trying to do there is get to a state where no prompt engineering is required at all. If you should just be able to answer a user's reasonable request. And if there's something that's not clear, then the app should just be asking for clarification or offering multiple suggestions, things like that. But then you can also think about people trying to build applications with LLMs. And really what we're trying to do here is make that process as simple and easy as possible. If Gemini doesn't understand something in your prompt, then it should be asking you about that when you're developing your application rather than when you're deploying it. And really what we're doing in parallel is kind of coming up with design patterns, much the same way that programming languages evolved. And you got good design patterns for building applications in standard programming languages. I see the same thing happening in LLM. So you can imagine sort of guidebooks and things like that, allowing you to sort of almost take off the shelf an example bit of code and then customize that to your specific application. When we talk about multimodal, I don't think anything should really be changing here in terms of our prompting techniques. One thing is that we're a little bit earlier in our journey for multimodal prompts than we are for text. So maybe we're still understanding where the gaps are. But I think it's actually really, really cool to try prompting like the Gemini app by voice. Because what you see there, or certainly what I see, is a really impressive performance, despite the prompts really being less well written than they are in text. Like if I'm talking to the Gemini app, it'll be full of ums and ahs, and I might go back and correct my sentence. I wouldn't do that if I was text prompting. And yet, what you really see is like a very coherent, fluent process.
Excellent. I love the recommendation or the sort of forecast that in the future models will be asking for clarifying questions, or they'll be pulling in additional context to help support users' requests, and make sure that they have the best possible outputs. So it sounds like a brave new world. I'm very excited for it in the future. Excellent. Next question is all about Vertex AI. So Vertex AI is rapidly evolving with new features and capabilities. Looking ahead, what are some of the key emerging trends in enterprise AI that you're most excited about, and how is Vertex AI positioned to help businesses leverage those for real-world impact? Warren and Arena, do you want to answer?
Yeah, sure. I'll go first. Arena, feel free to fill in. I think that when I look at like where we were and where we're going now, talking to customers, we're in this kind of large place of business, process automation, where it was, how do I understand unstructured data? How do I pull it out and do things with it? What we're seeing now, and I was playing with the agentic frameworks and some latest models last week, is moving to this place of being able to understand and reason to kind of do deep research type things. So way beyond, I just want to take this unstructured data and understand what it is, to, hey, can I do comparative analysis of things? And so when I was playing with the agent, the model actually was smart enough to know that it didn't have the latest information, and then invoked a tool to go out actually on the web and find the latest information and bring it into the analysis I was doing. And so it becomes much easier for you to do kind of some of this deep analysis and understanding of the data in the world. And so I think I see a ton of that in enterprises going on, where they're really getting beyond just being able to search and understand that they've got a bunch of unstructured data and what to do with it. Irina, you want to fill in?
I think that sounds good.
Great.
Excellent. And I know that the question around evals and how to adequately evaluate these more agentic workflows is something that many companies are thinking about and starting to pioneer. So excited to hear more about Arena's work in evals later on as well. Cool. So next question is for everyone on the call. Looking ahead 1 to 3 years, what specific task or capability do you believe foundational models will unlock that seems challenging or impossible today? Conversely, what inherent limitations do you think will persist despite all of the progress that we've made over the last couple of years, and especially in the last several months? So just given that we have a lot of folks on the call, let's keep it brief. So around just 2 to 3 sentences. And to start, Matt, do you want to go first?
Sure. 3 years in AI is 100 years in human life. So that's a good question. I think the way we build software and the way we use software will radically change in ways that people are still not realizing. I would summarize as that.
Yeah. And Logan, what about you? What do you think will be different in the next 1 to 3 years?
Yeah, I think the whole code generation, software engineering stuff is going to continue to take off. But I think the thing that is most interesting to me is, I think, on the context of what's not going to happen, I do think the models are still going to be bad if you don't give them enough context. I feel like this is not going to be a solved problem if you just ask a really basic question and expect the model to be able to do some miraculous thing for you. I think you're still going to be disappointed in a few years. Maybe the models will be smart enough to know that they have to ask a bunch of follow-up questions or something like that in the next 1 to 3 years, but that that piece is still going to persist.
Yeah, absolutely. It's just like today, if you ask a person to solve a task or to do something for you, you still need to give them enough background information to be successful and to point them in the right direction. Irina, do you want to go next?
I think mine is kind of similar from the eval lens. I think we will see less issues with how to automate eval flows, but we will still be at the point where if you don't give the model your criteria and what you care about and what you define as good, there is just no way to know that. And that can be provided in context or somewhere else, but you will still need to provide that somehow.
Absolutely. And Karen?
I might bring it back to the previous question and say that in a few years, I hope that prompt engineering will be a thing of the past, and I expect it to be. But like everyone else says, the models will never be able to read your mind, and people have to get more into the mindset of just being super clear and specific on their intention.
Yeah, and Warren?
I think even in this exists today, but I think it gets worse is over time, which is enterprises especially are not built around the ability to move super quickly. And so anything that happened 6 months ago, that was 2 generations ago. And so the ability for you to keep up and make sure that you design your, the way that you roll out software, the way that you put it in production, that you can actually do that in an agile way that allows you to take the latest and greatest. I think that that's one of the big issues that folks are facing now and will continue to face as we move forward.
Excellent. And thank you so much to everyone who's dialed in this week to learn more about what's being built and to learn how to incorporate it into your businesses, into your work, or into your personal projects. That is one of the first steps that you can do to make sure that you're staying up to date and that as all of these great new features get released, you are on top of all of them. So good work to everybody dialed in today and learning more through the Kaggle Generative AI Intensive course. The next question that we have is our first community question from Donna.Ophi. Thank you for adding this on Discord. How can AI system design and prompt engineering be optimized to improve energy efficiency, computational performance, so things like speed and accuracy, and reduce environmental impact while maintaining output model quality? So Logan, would you like to take a stab at this one?
Yeah, this is an interesting question. I think there's a bunch of different dimensions. I think one of them is at some layer, like different API services have ways to help with this. Like you could do prompt caching as an example. I think there's also like, another angle of this is like batch APIs. Like you can take sort of, the fixed cost of the fixed requirements of having services just like running all the time and find times when there's like idle compute just sitting around there and be able to sort of flatten out and make sure that, the compute is being used from the energy efficiency standpoint. You could imagine a world where like you say in the future, this doesn't exist yet, but you could say I'm a batch API customer and I care a lot about the environmental impact. So actually try to run my batches times when, data centers are more likely to be using renewable energy or something like that. So I think there's a lot of degrees of freedom and dimensions in which you could do this.
Absolutely. And I know that, Google's been investing a lot in smaller models, especially smaller open models, and that can help reduce the environmental impact footprint as well. If you're using something that's on device as opposed to pinging a server with a larger model. So it's been really inspiring to see the creative ways that the community is kind of rallying around and making these workloads more efficient in real time. Yeah. Next question. This is from Channing Ogden, again from Discord. How can judge models be selected and customized efficiently to minimize compounded bias and accuracy issues, building confidence without relying solely on repeated evals? Irina, do you want to take this one?
Yes, that's a great question and something I'm thinking about a lot. How do you actually build trust in all the judge models and autorators that you use? So I kind of think about 3 areas here. First, you just need to have a good foundation, right? So do I use a state-of-the-art model as a judge, and do I have some core techniques in place to mitigate bias? So just a couple examples. You already mentioned multi-sampling, right? So not relying on the first answer. And there's other things like flipping, because you need to flip orders. as these models show a position bias. They prefer the first or the second in a pairwise comparison. So this would be kind of the first step. And then I would say evaluate your judge. It's yet another LLM application, so you want to test it. And this doesn't have to be a lot of data, but some basic understanding if there's alignment between your human experts or your own judgment and what the judge says on, again, your very specific data. And if you don't see that alignment, and this is the third thing, start with prompt engineering, right? We already spoke about this a lot today, but are the criteria that you give the judge clear and specific? I often see hidden criteria, so users implicitly consider something, but they don't really explicitly state it in the autorator prompt. And as Kieran said, maybe in the future, they can ask clarifying questions, but they don't do that today. So this is something you have to think about. And then after you've done this, and you see that refining the prompt doesn't really close the alignment gap between you and the judge, then you can explore more advanced techniques. So maybe the data set level criteria that you're working with, they just don't fit your data set. It's too diverse. So maybe you need something like per item rubrics instead of universal criteria. Potentially you might consider fine-tuning your judge because your data set is so specific. But again, I would start with the prompt engineering if you see some misalignment between you and the judge model.
Excellent. I feel like we all just got a crash course in evaluating and sort of perfecting judge models. This is wonderful, and I hope we get to cover a little bit more of it later on in the week. Cool. Next question from Sarkar42 is writing the prompt appropriately prompt engineering or setting up the number of tokens, temperature, top P as prompt engineering, or both? And Anant, do you want to take a stab at answering this question? I'd also love to hear everyone's initial thoughts around prompt engineering. What is it? Why is it useful? And what exactly does it entail?
So maybe I'll just give a quick overview, and then the rest can take over. So I see the prompt part of the prompt engineering as the input, like in traditional ML models where there were features. So prompt is the input to the model, while the other parameters, the generation or decoding parameters like top P, temperature, these are operating at the output level where we kind of, with the fixed input, what else we can modify the output to kind of ensure that the tokens that are selected and sampled are done so in a way that optimizes the response for the task. Anybody else want to take a stab at this? Maybe Matt or Kieran?
Sure. I'll ask Kieran to cover his ears as I say this, but like my opinion is prompt engineering is a little bit of an art, right? It's a little bit of try and error. It's a little bit of let me test this with multiple models. Let me test this with multiple temperature settings. Does a smaller model can do this job, or do I need a larger model? Like a lot of these things I put in the bucket of prompt engineering, which is experimentation over and over again until you find the optimal way of working for your scenario.
And yeah, I'd agree with the art point at the minute. Like I see a future where there's far less art involved, and if we think about this sort of specific question, whether you call it prompt engineering or LLM engineering or whatever, these are all things as a developer that you have to think about. And there are various knobs that you can control. And you may not, you need to play with them a bit to build up an appreciation of the effects that they're going to have. And there's something that I would expect the need to go down for in the future as well. Like temperature is really just a way of balancing your creativity and like increasing your creativity to make sure you don't get the same response every time. And that's I guess a knob that we expect to stay, but be clear on what these parameters are doing and expect things to look a bit different in the future.
Just one thing to add on to that, for those of you who haven't read the prompt engineering white paper yet, we have a section on automated prompt engineering, which kind of crafts the prompt, uses together with the evaluation topic. It evaluates and crafts it for you. So have a look at that. It's very useful for your projects.
Yeah, absolutely. Next question. Hallucination is a major challenge for large language models. Techniques like RAG and prompt engineering can help, but what are the most effective methods that Google uses in Gemini 2 to minimize incorrect or misleading outputs? Are there trade-offs between reducing hallucinations and model creativity? Kieran, do you want to take a stab at this one?
Sure, absolutely. So reducing hallucinations, or this is an area that we call factuality as well. It's one of our key areas of focus. It's one of the things that was very apparent in LLMs in the early days, and it's critical to make them most useful going forwards. And I think there has been a lot of progress over the last couple of years. When I think about hallucinations, I think of it in terms of two different framings. One is whether Gemini is trying to answer a question or provide an answer based on a bit of context that has been input. So that can be RAG, but it can also be like answering questions over a document that you provide. And also, if you look at the generative experience in Google search, that's what happens. Like Gemini will go away and do a search, and then sort of summarize those results for you. So it's able to produce its answer based entirely on knowledge that is being provided to it. And then there's a second one, which is where Gemini is answering essentially from its training data. Or if you think of a human analogy, it's kind of like answering from your education or your memory. The first is always going to be inherently a bit easier for it to do, and probably a safer bet. It's a lot easier for me to verify an answer if I'm looking at some source materials in front of me than if I'm having to sort of trawl through some distant knowledge of facts in my memory. Really, if you're trying to reduce hallucinations, finding ways to ground to the input is a very good strategy. And Vertex offers search grounding as an option on the API. So what you're really doing there is giving verifiable references to justify the answer that is coming out. Beyond that, you can be explicit in your prompt about what your requirements here are. That may help. And you can also add on explicit verification steps at the end. If you want to be really mindful about your factuality, LLMs are also very good at verifying answers and checking whether an answer coming back meets a certain criteria. So you can try that strategy, even maybe combined with self-correction to go away and correct any errors that you see. And in terms of the balance between factuality and creativity, there is a trade-off there. It's difficult to write a very creative poem that is grounded in sort of real fact. But something to be aware of, coming back to the previous point about essentially the temperature knob. When you increase the temperature, what you're doing is you're making it more likely for the model to pick a less probable token, because these are probabilistic models. So when you're exploring your factuality, you can play it safe and turn the temperature right down to 0. And you can also look empirically at the results that you're getting back as you increase that to see what is the right balance for you in your use case.
Absolutely. Just like Warren was mentioning a little bit earlier, I love all of the knobs and dials that you can use to ground and to reduce the likelihood of hallucinations for models, things like search grounding or code execution. These are all wonderful methods for getting the right kinds of outputs from the models that we have available today. And with that, thank you so much to all of our expert guests for coming today, for getting to share a little bit more about what you're working on and to answer all of our great community questions. We really appreciate you and your time, and am looking forward to seeing what y'all build and release over the course of the next several months. This has been excellent. Thank you. Wonderful. And now, one of the most exciting parts of the sort of Kaggle Generative AI intensive course, at least to me, I'm delighted to welcome onto the stage Anant, who is going to be going over our code labs and demos, as well as giving a brief overview of some of the content that y'all should have been learning about over the course of the last 24 hours. Take it away, Anant.
Thanks, Paige. So hi, everyone. We are aware that some of you are directly joining for the live stream, and I'm going to give you a quick overview of the white papers and then move on to the code labs to give you a flavor of what you learned or will learn if you haven't had a chance to dive into it. So let's start off with the white paper overview. So we had two white papers, one on foundational models and the one on prompt engineering. And first, in the foundational model, we looked at the basically how these AI models, which often use a transformer architecture, leverage the attention mechanism to train on like large corpus and leverage large context. We also looked at architectural variations like mixture of experts, how they can improve efficiency and quality. We also saw the rapid evolution through different models, all the way from BERT, PaLM to Gemini, along with several open models as well, driven by scaling, data, and model size. Next, we looked at how these models are trained and adapted. So they start off with pre-training on vast data sets for basically just building a general understanding of the modality they're training on. Then often to ensure that we looked at basically to ensure that they follow the instructions that you provide, they go through a supervised fine-tuning stage to improve instruction following and to make them more task specific. And lastly, we looked at how reinforcement learning from human feedback, also called RLHF, aligns the outputs with human preferences for basically things like helpfulness and safety. Then we looked at, tuning these models, especially to tasks, downstream tasks, quite expensive. So we use various parameter efficient methods, which make tuning these models very efficient. We all in the second paper on prompt engineering, right? This is a core part of what we discussed earlier on in the Q&A session. We looked at the various prompting techniques, all the way from generation or sampling parameters such as temperature, which controls the randomness and the diversity of the output, top P and top K, and how it's crucial to balance predictability and creativity depending on the task you are using them for. We also looked at various prompting techniques, all the way from basic zero-shot techniques, where you just ask the LLM, to providing examples to the LLM to make it more effective for the tasks that you're using it for. We also looked at structuring prompts with system instructions, task-relevant context, or assigning a role also can help guide the model. And we also then later on looked at things like for more complex problems, which involve reasoning, chain of thought models, step-up prompting, and other techniques which can help with enhance complex problem solving for models. Finally, in the foundational model chapter, we looked at how to optimize the models for speed and efficiency. As discussed earlier on in one of the Q&A questions, there are various techniques that we can use for that, from quantization, distillation, as well as various other techniques such as speculative decoding, which basically makes models faster and cheaper. I would recommend looking into the podcast or white paper to know more about them. And then finally, we concluded the whole paper with looking at evaluation and best practices for evaluating your models using other LLMs as well as simpler techniques. So yes, now that we have kind of gotten an overview of what we looked at in the reading assignments, let us dive straight into, I'm going to be sharing my screen for the code lab. So hope everybody can see my screen. So the first code lab that you all have received basically dives into prompt engineering and how we can utilize these models for your applications. So the first part of it is basically just using Gemini 2.0 Flash, which is one of our most performance and speed balanced models that we've released. And this we use it to see how we can do simple prompting here. Then we move on from this single turn prompting, where we just give an input and get an output, to a multi-turn structure where we can have a conversation with the model, and the API automatically retains previous context to inform further responses by the model for conversational applications. And then we looked at the various options that you can of models that we can utilize from the API beyond just 2.0 Flash. This is you can also use your own tuned models and they provide them as specify the model for your API call. And the next part of the code lab, which you'll be learning from here, is the how to modify the various generation parameters, and you'll be playing around with some of them. For instance, output length. This is basically telling the model to limit the amount of tokens it's generating. It's a hard limit, keep in mind, so it does not automatically tell the model to automatically generate a smaller, a concise response. It essentially just truncates the response. So if you are going to ask the model to make a 1,000-word essay and give it a very short response, max response length, it's going to just cut off the essay abruptly. So keep that in mind, but it can help you control costs. Then we looked at something we have talked about earlier, what Kiran mentioned earlier, temperature. This basically controls the degree of randomness in token selection. And long story short, a higher temperature leads to more diverse outputs, while a lower temperature leads to more predictable, deterministic outputs. We looked at an example of how, when asking the model to pick a color, a random color, it can pick different colors across different iterations when the temperature is higher, while for a lower temperature, it tends to center around one single color. Then we also looked at things like top P, how we can play around with knobs like top P and top K, which also kind of constrain the tokens that the model selects at decoding time or generation time. This can help you with your with selecting the amount of randomness and determinism in your applications. And then towards the last section of the first collab, we looked at various prompting techniques that we have discussed earlier. Zero shot, where we give it a prompt and give it a task and ask a response, all the way to using constraining the response. So instead of a free text field where we just ask the model to generate some text without the constraints, we can also kind of limit the responses that the model can provide us, the enumeration set. And we looked at also other techniques like one shot and few shot, where we provide some input and output examples to help it perform better on certain tasks. And things like JSON mode, where we can structure, give it a certain, provide the model to a certain structure for its output, which can help it structure its output in a way which can easily be parsed by the downstream models. And then chain of thought reasoning and other prompting techniques as well, and React as well. So that was the first collab. And moving on to the second collab, which is also, we're doing it for the first time this year, is the one on evaluation and structured output. So it's, as we learned in the podcast and our discussion earlier, evaluating the response is pretty crucial, especially for your tasks. And we look in this code lab, we look at how you can basically set up some context as like a PDF for one of our technical reports, and utilize an LLM as an evaluator where to evaluate this. For instance, we provide in the first part, we see how we can give it a point-wise evaluation prompt where we carefully craft a prompt for an LLM to evaluate the response of another LLM's response with respect to what the prompt that was provided, and it evaluates it with a score of 1 to 5 with respect to a carefully crafted rubrics, which we have defined here. And we see how this can be used, and it gives some reasoning as well as a score. And we see here that we get a score as well as the reasoning behind it as well. Then we play around to see how you can improve or reduce the score and what makes a good prompt. So for example, explaining our technical reports to a 5-year-old is obviously going to lead to a slightly lower response by the evaluator, because we often have the word puppy, which is not present in our technical report. So good way to see the difference, and we get a very expected score of 1. And in the last part of our collab, we discuss various techniques for using evaluation in practice. For instance, we discuss point-wise evaluation for summarization, where we kind of take a response, take a prompt which generated a response, and have an LLM evaluator determine on a scale of 1 to 5 what score does it get. However, it could be, because the scale of 1 to 5 is not very fine-grained, that there's a tie between some responses. And this is where point-wise evaluation is sometimes does not suffice, and it's often useful to have pairwise evaluation as well, where we give 2 responses to a particular prompt and have the LLM as a judge select that response. This is what we also see, and then we finally end the collab with seeing how we can. It's often useful, as Irina mentioned earlier, to generate multiple responses by the LLM autorated judge instead of just selecting the first response, to ensure that the score that you get is not just due to noise and stochasticity. So yeah, so it's a lot to cover, but off to you, Paige, for the pop quiz.
Excellent. Thank you so much, Anand, and to Mark McDonald, who helped create many of these code labs. Y'all have done a great job of making all of the concepts that are being discussed in the white papers and in the Q&A sections real. And I'm really looking forward to seeing what people build and their initial impressions of the code labs. So this is very, very cool. Thank you. With that, I'm going to go ahead and move into the pop quiz. So I'm going to bring up onto the screen some questions that hopefully folks will be able to answer now that you've had this 24-hour crash course in prompt engineering and foundational models. To start with, our first question: which Gemini configuration setting controls the degree of randomness in the selection of the next predicted token? Is it temperature? Is it top K? Is it top P? Or is it the output token count? Remember back to the white paper, as well as some of the questions that Kieran was answering today. Which Gemini configuration setting controls the degree of randomness in the selection of the next predicted token? So hopefully everybody's had a chance to jot this down on either a pen or a piece of paper with a pen or a pencil, or if you're just kind of taking notes in a doc. But the answer is a temperature. So hopefully everyone got this right. Question 2. Which of the following is not a technique used to accelerate inference in large language models? Is it quantization? Is it distillation? Is it flash attention, or is it fine tuning? Again, and you're looking for what is not a technique to accelerate inference in large language models. I'm going to count down 5, 4, 3, 2, 1. And the correct answer is D, fine tuning. Fine tuning is not a technique used to accelerate inference. Question number 3, which of the following is a unique characteristic of the Gemini family of large language models? Is it A, Gemini models were the first to introduce the concept of unsupervised pre-training? B, Gemini models can support multimodal inputs? C, Gemini models are decoder only? Or D, Gemini models can support a context window of up to 2 million tokens? What is a unique characteristic of the Gemini family of large language models? On a countdown, 5, 4, 3, 2, 1. The correct answer is D. Gemini models can support a context window of up to 2 million tokens. And hopefully, if you've been experimenting with some of our pro models in AI.dev, which is Google AI Studio, you should have been experimenting with this firsthand. Question number 4, how does reinforcement learning from human feedback, RLHF, improve large language models? Is it A, by training the model on a massive data set of unlabeled text? Is it B, by using a reward model to incentivize the generation of human preferred responses? Is it C, by reducing the number of parameters in the model for faster inference? Or is it D, by converting the model into a recurrent neural network for improved performance? How does RLHF improve large language models? And hopefully everybody remembers this a little bit from the white papers, as well as through some of the questions that we were answering today. I'm going to count down 5, 4, 3, 2, 1. And the correct answer is B. RLHF uses a reward model to incentivize the generation of human preferred responses. Question number 5. Which technique enhances an LLM's reasoning abilities by prompting it to produce intermediate reasoning steps, leading to more accurate answers? Is it A, zero-shot prompting, B, step-back prompting, C, self-consistent prompting, or D, chain-of-thought prompting? Hopefully everyone is thinking back to the white papers. And hopefully you've also been experimenting with this prompting technique as you were kind of playing with the Gemini models in AI Studio, as well as in your Kaggle Code Labs. But the answer is D, chain of thought prompting. Chain of thought prompting helps the model show intermediate reasoning steps, which often leads to more accurate answers. So thank you to everyone for participating today. Hopefully you all scored 100% correct on your pop quiz. And if you didn't, you learned something along the way. So thank you for kind of testing your new knowledge and skills and capabilities. And the last question, what is a minimum GPU memory needed for inference on a 3 billion parameter model using standard float precision? This is kind of an extra bonus question, which you should have been reading the white papers in order to answer. Is it 3 gigabytes, 6, 12, or 24? How much GPU memory would you need to run a 3 billion parameter model? And the correct answer is 12. So hopefully everyone got this right. And if not, refer back to the white paper to learn more. So thank you so much again for dialing in from all of the folks that are working on our Q&As, the Kaggle team, the Google DeepMind team, the organizing team. A huge round of applause for everybody involved. Thank you so much and look forward to seeing you tomorrow.